let's be real, we're drowning in data. It's everywhere. Your social media feed, your bank account, all of it. But have you ever just stopped and wondered, how does it all work? How does a computer keep track of literally everything without just, crashing? Well, the answer is actually pretty elegant, and it's the secret engine behind our entire digital world. I mean, think about it. You pull out your phone, you type in a song title, and bam, there it is, instantly. That's not magic, right? It's all about organization. It's the same exact principle that lets your GPS find the quickest route home or an online store keep track of millions of items. So the problem is handling all this data with insane speed. What's the solution? Well, the solution, when you get right down to it, is having a system for getting organized. Computers are just like us. They just can't function in total chaos. They need a logical, systematic way to store data, find it again, and change it. And this core idea has a name, and that's what we're going to dive into today. In that name is a data structure. The idea itself is super straightforward. A data structure is simply a method for organizing data. That's it. It's the how behind pretty much everything your computer does with information. It's one of the most fundamental concepts in computer science, and honestly, it's what makes our digital lives even possible. A really great way to picture this is to imagine you're designing a bunch of filing cabinets. You wouldn't use the same cabinet for your tax documents that you'd use for old photos, right? Each one needs a different design to be useful. Well, data structures are basically the blueprints for these digital filing cabinets. Each one is perfectly designed for a specific kind of data and a specific kind of job. So let's peel back the layers a little bit and see what these blueprints actually look like, because they are not all the same, not by a long shot. In fact, there's a whole family of them, and each one has its own unique strengths and weaknesses. And this chart right here gives us the big picture. Seriously, think of it as the data structure family tree. You can see at the very top, everything splits into two main branches, primitive and non-primitive. Then that non-primitive branch splits again into linear and non-linear. This chart is our roadmap, and it shows us how all these different ways of organizing information are related to each other. Okay, so at the very highest level, the family is split right in two. First up, you've got primitive data types. These are the absolute basics, the Lego bricks of programming. We're talking about simple things like numbers or individual letters of text. Then you've got the non-primitive structures. These are the more complex containers that you build using those basic primitive blocks. All right, so if we follow that non-primitive branch down the family tree, we find another really important distinction. This one isn't so much about what the structure holds, but more about how it behaves in the computer's memory. And this slide lays it out perfectly, the split between static and dynamic structures. A static structure, like the classic array we'll talk about in a second, has a fixed size. You decide how big it is up front, and that's it. A dynamic structure, on the other hand, is flexible. It can grow or shrink while the program is actually running. Deciding between a fixed-sized box and a flexible bag has huge consequences for how well your program runs. Okay, to make all this feel a little less abstract, let's zoom in on probably the most fundamental data structure of all, the array. It's the perfect place to start because once you know what an array is, you'll start seeing it absolutely everywhere in programming. So what exactly is an array? At its heart, it's just a collection of items that are all the same type, like a list of numbers or a list of people's names, all stored together under one name. So instead of making 10 different variables for 10 different test scores, you just make one array to hold all 10. It's all about simple, efficient grouping. And this is a fantastic way to visualize it. An array is just like a row of connected, numbered mailboxes. Each piece of your data, which we call an element, gets its own little box. And every single box has a unique address called an index, so you can go straight to the one you're looking for instantly. But, and this is a big but, here is a crucial little detail you have to remember. Unlike how we normally count in the real world, computers almost always start counting from 0. So in a row of 6 mailboxes, the addresses aren't 1 through 6, they're 0 through 5. It's called zero-based indexing, and it's a little quirk that is so important to get right when you're programming. So what can you actually do with an array? Well, a bunch of fundamental things. You can traverse it, which just means visiting each box one by one. You can insert a new item. You can delete an old one. You can search for a specific item, or you can update an item that's already in there. These are the basic actions that make the whole structure so useful.
Okay, so we've looked at the array, but as we saw in that big family tree, it's just one of many, many options. And this brings us to what is maybe the most important question for any software developer. Which one do you choose for the job?
And this quote just hits the nail on the head. The performance of the apps on your phone, the websites you visit every day, the games you play, so much of that snappy, instant feeling comes down to this one decision. This isn't just some academic thing. It has very real, tangible effects on how we experience technology.
At the end of the day, it really comes down to this. Picking the right blueprint for the task is the difference between an app that feels fast and responsive and one that feels slow, sluggish, and clunky. Getting this choice right is one of the most important skills in all of programming.
And that kind of leaves us with a final thought to chew on. We've really only scratched the surface today by looking at the array. What about all those other branches on the family tree? The linked lists, the stacks, the trees? If this one simple structure is so powerful and essential, just imagine what's possible with the rest of the tools in a programmer's toolbox.